How's the homework going? Yeah, are there some questions you'll have for tomorrow? Were there some problems? You don't need to tell me now, but there is some stuff for us to do tomorrow in the tutorial. Yeah? Or there was no problem with any question? Are you sure? Alright, it doesn't matter. We'll find out tomorrow. Okay. Right, resolving vectors. If you can write that down, please. Look at you all so cold with your jackets on. It's so cute. You haven't gotten used to the weather yet. Not yet. Okay, resolving vectors. Well, you look like you're doing all right there. You don't have. Are you the only one without a jacket on?
It's really thick, so I have to.
Okay, it's too warm. Resolving vectors. Okay, so we said last time that we can add two vectors together, so we can certainly add a horizontal and vertical vector together, just like any two. And this is actually a common problem in mechanics. But so is the reverse. That is, taking a vector and writing it as the sum of a horizontal and vertical vector. So what am I saying here? Let's have a look at the picture, perhaps. So we learned last time how to add two vectors together. Let's say this one and this one. We'll call this one H and we'll call this one B. So we use the vector triangle. So we put this guy at the end here. Remember, tail with the head. And then this triangle here would be H plus V. Okay? But what we would like to do today is, if I start with this vector, which is the resultant, can I figure out what this one is and what this one was? Yeah? Mm-hmm. So, if you want to take two vectors and make it into one resultant vector, we call that just add the vectors together. But if you have one vector and you want to take it back to the two vectors it was, then we call this resolving the vectors. Okay? So this one is going from this one's going from horizontal and vertical to resultant, and this one's going from resultant to horizontal and vertical. So the verb is resolve, and the verb here is just add. In your maths class, have you done quadratics? Mm-hmm. And have you done factors?
Yeah.
So what's the verb when you have two factors and you make it into one quadratic? If you have two factors beside each other, mm-hmm, and you multiply them to make it into a quadratic.
So there's a formula.
Simplify?
Not quite simplify.
No, there's a formula.
Yeah, but I'm looking for just the verb. Like if you have two factors and you multiply them to make it one quadratic, what's that called in maths? I'm sure someone knows. No? Expand? Yeah? Yeah. And if you have one quadratic and you want to change it into two factors, factorize, yeah. So I'm giving you I'm trying to draw a comparison. So this is when you go from 2 to 1.
That's when you expand.
This is like expanding. And then 1 to 2, this is like factorizing. That, you see the comparison I'm making. So we want to learn how to do that today. Okay, continue. So let's have a look. This will be useful for the process. Good old Pythagoras Theorem. I know you have at least seen this before, so if you can write it down and the name. Is Pythagoras in most languages? Not Chinese though, but it's in Arabic. Pythagoras, yeah. You have to give it more passion when you say it. And Korean, and is it Pythagoras still? Korean? So it's the same, yeah. But not Chinese. What's his name? Do we know his name in Chinese? Okay, no problem, yeah. It's not Pythagoras, it's something different. Okay, so if you could just write his name down with his theorem. Okay, you got that? Yeah. I can't remember. It's something in Chinese. It's something like go D or something like that.
Yeah.
Yeah, something like this.
Yeah, exactly.
No, not exactly. No. I did a terrible job of that. Not exactly. Okay. So we can use Pythagoras to help us here. Before we look at how to resolve, let's just look at how to combine, how to add. So what is the magnitude of the vector 3 meters east and 4 meters north? Let's have a look at this one. So if you go 3 meters east, 4 meters north, then you have this result here. But my question is, what is the magnitude? How big is this? Well, if you know Pythagoras, you could work it out.
3 squared.
That's it, yeah. 3 squared plus 4 squared.
Yeah.
And let's just call this x. So you have x squared equals 3 squared plus 4 squared. So x squared equals 25. So x equals 5.
Mm-hmm.
Yeah. This symbol here, when you put the lines around it, this means...
Only positive.
Yes, it also means that, but it has two meanings. It means magnitude. So this means basically how big is or. That's what it means. So in this case, it's actually 5 meters is the magnitude. Okay. Can you write this example down? This is like our first example. Got that? Yeah? Yeah. Okay. Now, a little bit more vocabulary. So, when we have a triangle... Oh, by the way, what's the name of this type of triangle?
The right angle triangle.
Right angle triangle. And the angle is here. So we call this side the opposite. Because it's opposite the angle, we call this side the adjacent. Does anyone know what the word adjacent means in English?
Closest to.
The same.
Yeah, not quite closest to, I mean it could be closest to, but I think beside is a little bit more accurate. So, like neighbour. And hypotenuse is the longest side. Can you write these names down? Make sure you know. Well, I'd like you to write them down, but do most people know these?
Yeah.
Yeah. And does anybody recognise the word that's at the top of the slide?
Yeah.
You recognise that word? Yeah.
It was a hack in high school.
Hmm?
It was a hack in high school. They didn't
Yep.
use this.
Yeah, it's strange. No, I always remember this one from school. Have you seen this word? This one up here? Sohcahtoa? Do you know this word? You know this word? Kim, do you know this word? No, new word? Matt? New word?
Yeah.
Sohcahtoa? Ah. Do you know Sohcahtoa?
Yeah.
You know Sohcahtoa? What's Sohcahtoa? Sohcahtoa is, you watching? Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. You remember this from middle school perhaps. So you'll do this in maths class. Sine is opposite over hypotenuse. Cos adjacent over hypotenuse, and tan opposite over adjacent. So that's like Sohcahtoa. Sohcahtoa. Yeah? You've never seen this word?
I just know the sine, cosine.
You know the rules.
Yeah, but I don't know that one.
You'll do this in maths class with Joan anyway. But in fact, this one is the one that I care about the most, because by using tan inverse opposite over adjacent, you can figure out this angle. Now your calculator has the tan inverse function on it, I believe. It should certainly. Let's see. Yeah. You have your calculator? Yeah, so you know where this tan inverse is, yeah?
Shift sine, shift cosine.
Yeah, you have them, yeah. You got a calculator? Huh? What have you got? Great, okay. Do you know where this button is? Tan inverse. Do you know where it is, Matt?
Yeah.
Can you show him on his calculator? Yeah. Okay. So can you write? Yeah, here it is on mine. Shift tan inverse fraction. So what I want you to do is to write this formula down. Tan inverse opposite over adjacent gives us the theta here. We actually use that one a lot in physics. Of course, you can use sine and cos, but it's actually this one we use the most, because in most problems we always know the opposite and the adjacent in physics. Okay, let's continue. So I want to go back to this. Where's it gone? This one here I did. I want to know what is the direction. So we'll need to work out this angle. So using your calculator, give me the answer. Now don't forget, it's a direction, so you need to use north, south, east and west. So I want to know what this angle is.
53.1.
It sounds believable. So it's tan inverse 4 over 3. That's 53.1. So how would I write the answer? Like this.
North.
East, well I suppose you could go from the north. It would usually be east 53.1 degrees north. Yeah. Or you could say 53.1 north of east. This is a short little question. Just using the calculator. So that's the answer for that one. Okay. Got that? Yeah.
Why is it inverse?
Yeah, because now you'll do more in maths class, so just briefly I'll say I'll just call this x, this y and this theta. So the formula is tan theta equals x over y, the TOA. So therefore, theta is tan inverse x over y, because what you're doing is, if you have tan theta equals x over y, you actually want theta, not tan theta, so you put a tan inverse on the left and the right. And the effect is that this guy cancels this guy, so you're left with theta is tan inverse x over y. So basically, if you have an inverse here, the answer is an angle. But if you have no inverse, the answer is a fraction. But you'll have a whole chapter in maths on this in a few weeks. Yeah. Is that okay? Let's continue. So yeah, we have our other formulas, sine, cos, tan. And actually, whoops. Oh dear. Oh no. Where was I? How did it jump all the way back to the start? Okay. So, usually in physics, we know two things. Usually they give us the hypotenuse and the angle. And they often ask for what is the adjacent, what is the opposite. And what's the verb to ask for this? Do you remember what the verb is? No, the other one, the other way. Not this one. The verb, that means find the horizontal and the vertical. No, that's what you just said. No. I gave you two verbs at the start.
Add.
That's the other one. Resolve. It's also the name of the lesson. So we want to take the magnitude and the direction and resolve it into a horizontal and a vertical. Okay, let's see how to do that. Okay, so in red, we'll call this magnitude and this is direction. And the red is what we know. And what we want is this and this, which I'll call x and y. And that's what we want. Okay? So according to my formula, sine theta will be y over r. And cos theta will be x over the magnitude. So if I was to just bring this up here, I get the formula x is or cos theta and y is or sine theta. Now let's look at this. Remember we had this vector. We said this is 5 meters, and what did we say this was? 53.1 degrees. Yeah? And I ask you to resolve. So that is, I want you to find this, and I want you to find this. Yeah? We actually know the answer already. What should the answer be?
X is 3.
Yeah, it should be 3 and 4, okay? But let's use this new formula here. So this is supposed to be 5 cos 53.1, and this is supposed to be 5 sine 53.1. Let's see if that works. So there's my 53.1, okay? Let me just type in 5 cos, my answer, the 53.1. And what should I get here? I think we said this side was 3, didn't we? So let's see if I get 3. And I do. Okay? And if I change this to sine, I'll get 4 as well. So here's the shortcut. I'll just put it in here. If you have a vector and you know its magnitude and you know its direction, this side is magnitude multiplied by cos, and this side is magnitude multiplied by sine. And the quick way to remember this is the side that touches the angle, that's always the cos. Because sometimes what you have is something like this. You know, you might have in physics, you might have this thing, and then this thing will be on it, and then there will be a vector here, and then I might ask you to resolve, and I want to know what this is, and I want to know what this is, and you're saying, oh my goodness, which one's the cos and which one's the sine? So if the angle is here, you might think, well, maybe this is the cos, or maybe this is the cos. No, you just remember, the side that touches the angle is always the cos. So because the angle is here, it means this one's the cos and this one's the sine. Okay? So you definitely need to write this down. I don't know, it's a little messy, but this is kind of the key result here. This is kind of the quick resolve. Quick resolve. Okay. Have you got that written down? Okay. This quick resolve then is very useful. You don't want to be wasting time in the exam thinking about which is the cos and which is the sine. You just want to remember the one that touches the angle is the cos one. Okay, continue. Now, back to speed and velocity we were talking about last time. So to be a little bit more precise, we were talking about speed is the distance travelled. But actually, to use the language of vectors, speed, well, I wonder if actually, does anyone know? If we use the language of vectors and magnitude and direction and horizontal and vertical, does anyone know what speed is compared to velocity? I think some of you might, because we can actually say speed is the magnitude of velocity. So if you have a velocity vector, if you look here, let's say this is going 3 meters per second east and 4 meters per second north. What's the magnitude here? It's 5 meters per second. So we can actually say the speed is 5 meters per second, because the speed is the magnitude of the velocity vector. Okay, so there's another way to think about speed as a magnitude of velocity. So we just get this definition down. I thought some of you might have seen that before or not. No? Maybe. You won't confirm or deny. It's possible. Okay. We got that? Yeah, okay. So, next. I'm going to let you try this one before I do it, okay? So, just to be clear, you've got a vector, and it's 10 meters per second horizontally, and 20 meters per second vertically. I want the magnitude and the direction. So, I want the hypotenuse and the angle.
So it doesn't say the direction?
Doesn't matter.
Yeah. It's funny because in the exam, they do this as well. They don't say east and north, and sometimes the students get very unhappy with it. But it doesn't actually matter it doesn't matter if you draw it going left and down or left and up or whatever. As long as you keep the same picture for the whole question, it's fine. But most students would draw it right and up. Except one year I had a lot of students who drew it left and up. I don't know why they did that, except maybe they were Arabic. So we usually go for right and up.
Yeah.
So 10 and 20. So you've drawn it left.
No, right and up.
Oh, I couldn't see your little arrow there, yeah. How are we doing? Do we have answers? What did we get for the direction?
10 rather than 5. 63.4 degrees. Oh, the
direction, yeah. 63? Let's have a look. So did you type in shift?
Cosine.
Oops. Shift tan inverse 20 over 10 and 63.4 degrees.
Here's what
Oh, why did you use cos? Why not tan?
Yeah,
But that's fine. No, that's fine.
Yeah.
That's fine. Ah, dudes. All right. Did you get 63?
Yeah, 63.4.
No.
No. Okay. And then magnitude. What did we get?
10 rather than
Yeah. In fact, it's weird, but in physics exam that he prefers when you give your answer as a decimal. Yeah. So it'd be 22.4 meters per second.
That's 3 sigma.
Yeah, that's what he likes. Just you have to give him what he wants. Yeah?
Who's he?
I know. I'll discuss later with you. Okay. Next example. I think I have another one here. I think just one more. Yeah, one more. Okay. A ship is sailing 15 kilometers an hour at a bearing of 30. Who remembers what a bearing of 30 is?
From the north.
From the north. Clockwise or anti-clockwise? Yeah, good. I want you to resolve this. I want you to give me the horizontal and the vertical, the east and the north vector. Yeah. So this is where you have to use that trick of the cos and the sine. Okay, try this one now. Now, how are we doing with this one? Siba, you think you have an answer? Yeah. Who else thinks they have an answer? Kim? Not yet? Okay. Okay. How are we doing up the front here? George? Okay. Okay. Who has answered? George or Matt, you have an answer? Yeah? Yeah. You've got an answer? No? No? Okay. Let's have a look. You can tell me what the problem was. So, east, west, north, south. So it's going 15 kilometers an hour at 30. So it's like this. That's 30 and that's 15 kilometers. So I need this and this. Now, is this side here cos or sine?
Sine.
Very good. It's 15 sine 30 degrees. And the other fella? Whoa. Whoa. Wait. Okay. This one, 15 cos 30 degrees. Okay. Did somebody type these in? Well, what's 15 sine 30?
7.5.
7.5 exact? Oh, yeah, that makes sense. 7.5 kilometers per hour. So that's one of the answers. And then this one? 14? 13 exact?
12.9.
Okay, so 13 then. 13 kilometers per hour is the other answer.
Yeah.
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 So, Kim, maybe you can tell me what confused you in this question.
I just didn't got the 15.
Say again?
I just didn't got the 15 rows in that line.
Is it the picture?
Hmm?
Like, is it how to draw the picture?
Mm-hmm.
Yeah, because of the English. Is it? Yeah, because in the exam they usually give you a diagram.
Mm-hmm.
Not always. Like maybe 90% of the time they'll give you a diagram, but sometimes they don't.
Wrong.
Did you draw it wrong?
Yeah, but I got the answer.
But you have it the wrong way around? Yeah, yeah. You need to be careful with our English then. Did you got it? Yeah, yeah, okay, okay. Is it okay now? Should I believe you?
Yeah.
Oh, I don't think you should play poker. I'm not convinced. And up the front here. Is this okay? Is this okay? This one? Are you sure?
Yeah.
100% sure? See, he has a better poker face. Yeah. Right. Okay. Well, anyways, let's see. I think that's it then. Okay. So let me just close this here. You probably want to keep working and then have your lunch sooner rather than to take a break, right? I would think so. Anyways, you had none at 9 o'clock, so you shouldn't be too tired. Yeah, we'll start the next lesson in 10 minutes. I'll just give you a few minutes to practice, get started on your homework then, okay? So that's... Yeah, page 11 there. There's a few questions there. They're not long, but there's 7 questions there if you want to get started.
Page 10?
Is it 10? 10 or 10, is it? Yeah.
10?
Well, I guess it depends which book you're in. It's called Result. It's this one, yeah. Yeah, that one, yeah.